Hello everyone, welcome to our channel Online Classroom. Today we are going to discuss the topic Echelon form of a matrix. Well, what is Echelon form of a matrix? That is the main topic for all of us. Okay, look, this is the basic definition. Suppose a matrix is given, that is say A, it is called Echelon matrix or Echelon form, whatever, if we moves to downward and the leading number of zeros are actually increasing. Look at this particular matrix. This is basically identity matrix of order 3 cross 3. But if we moves to downward in this direction, then number of leading zero, this is 1, this is 2. So number of leading zero, these are basically increasing. So this is the basic idea of Echelon matrix. Now focus on this matrix. Look, if I moves to downward, then here it is leading 0 1, here it is 3, and here it is 4. So number of leading 0 actually increasing. So this is an Echelon form. Okay. Now if we moves to this example, look, this is leading 0 1, 2, this is 3, and this is say 5. So number of leading 0 actually increasing if we focus on the downward position. Okay. But what about this particular matrix? Look, number of leading 0, this is 1. But here we observe that 1, 2, minus 3, 6. This particular row actually incorporated here. That means leading 0, number of leading 0 increasing, this particular theme actually breaks down in this position. Okay. That's why it is not an Echelon form. So we can't say that this is Echelon form of a matrix. If we focus on another example, this one, look, leading 0 1, leading 0 here basically 5, but next if we focus on the third row, leading element is basically 1, that means non-zero. So we can say that this is not an Echelon form of a matrix. That's why we discard that particular matrix in case of Echelon form. Okay, so that is the Echelon form of a matrix basic definition. Now we will try to focus on some problem. Suppose any kind of matrix is given. Suppose this is a matrix. Okay, this in this particular matrix we consider basically 4 row and 4 columns. So order is 4 cross 4. Now since it is a square matrix, we have to find out the Echelon form of this matrix. Okay, question will be how. Look, the first element is 1 in this position. What is our target? Our target is to create 0 in this position, and this position using the first element. That means if I multiply the first row by 2 and subtract from this particular row, that will create 0 in this position. Okay. To create 0 in this position, we need to add first row and third row. Okay, that will create 0 in this position. That's why R3 plus R1, and previous one is R2 minus R1. And if I focus on last one, basically this is nothing but if we multiply 2 here and just subtract from it, that will create 0 in this position. So it will be R4 minus 2R1. Okay, basically it is nothing but R2 minus 2R1, it will be 2R1, okay, to create 0 in this position. So after that we have 0 in first column, okay, and second, third and other columns are changed. Okay, now what is next target? Using this particular one or using this particular element, we will try to create 0 in this position. Look, if we add this two row, okay, that will create 0 in this position. That means R3 dashed, it will be nothing but R3 plus R2. This is the operation that will create 0 in this position. So ultimately we get this particular matrix, modified matrix. Look, here leading number of leading 0, this is 1, this is 3, but this is 2. So still it is not an Echelon form. But we observe that if we focus on third row and fourth row, if we interchange it, if we interchange third and fourth row, it becomes this one. And in this particular matrix, we observe that if we focus on downward position, number of leading 0, these actually increasing. Here it is 1, here it is 2, here it is 3. So it is increasing. Okay. So that's why it is the required echelon form. Okay. That means if square matrix is given, perform the operations, row operations one by one, and ultimately you can also apply your interchange of rows. Ultimately you get the corresponding echelon matrix. So this is the echelon form of this matrix, and we also focus that, or we also observe that in this matrix we have 4 non-zero rows. That means the rank of this corresponding matrix will be 4. So whenever you get the echelon form, you can easily judge the rank of this matrix. So this is one of the application of echelon form. Okay. Now we move to another example. In the previous example, we consider square matrix, but here we consider rectangular matrix. Okay. Physically 4 rows are there and 5 columns are there. Okay. Now we have to judge the echelon form. Obviously our target is to create 0 in this position, in this position, and in this position. Okay. Using this particular leading element 1. Okay. That means the first operation is nothing but just multiply 2 here and subtract from the third row. That means R3 minus 2 R1. So that will create 0 in this position. And in the fourth row, if I multiply the first row by 3 and subtract from the fourth row, that will create 0 in this position. Okay. So this is the modified matrix. But if we focus on this matrix, still it is not an echelon form. Okay. Leading 0 is 2, 2, 2. This is not an echelon form. Okay. So obviously our target is to create 0 in this position and in this position using the particular member 2. Okay. That means if we add these two members, it will create 0. And if we just multiply this particular element or this particular row by 5 by 2 and add with this particular row, it will create 0 in this position. So that's why we will perform the operations and ultimately we get the corresponding matrix. Now we can also interchange the third row and fourth row. Okay, because after performing R3 plus R2, we get 0 row in third position and the fourth position or fourth row is unchanged. That's why we just interchange those two rows. Okay, that means it will gives us this particular form. And we also observe that the corresponding number of, if we focus on the downward position, the leading 0 actually increasing, but it is same in first, second and third row positions. So that's why we will need to perform another operation. As I said earlier, that using this particular 2, we will multiply 5 by 2 here. That will gives us 5, and if we add those two rows, it will gives us the modified matrix. Now in this matrix, if I focus on it, look, now if we focus on downward position, the number of leading 0 actually increasing. Here it is 2, 3 and 5. So this is the required echelon form of this matrix. And in this matrix, we observe that basically 1, 2, 3. 3 non-zero rows are there. That means the rank of this corresponding matrix will be 3. So that is the usefulness of this echelon form. So in this lecture, we will discuss, we already discussed basically the square and rectangular matrix echelon form. Okay, so in the next video, we will discuss some other operations and other forms of matrices. So thanks for listening us.